Hello, you're watching the second part of building a web application using ASP.NET Core 1.0, Aurelia, TypeScript, and Webpack in Visual Studio Code. Hi, I'm Raja Mani. I live in San Jose, California, and I'm very passionate about technologies and I've been programming since 1988. I blog in opensource.netter.blogspot.com. This video series is a complement of the blog post series in opensource.netter.blogspot.com. Prerequisites for this part: you should have watched part 1. The YouTube video link is available down below in the description. If you scroll down to the description, I've pasted the link for part 1. Then you need the part 1 source code. I've also posted the GitHub link for my source code. In this part, we're going to see how to set up client tools like TypeScript 2.x and Typings tool. What is the project organization that is most suited for our client-side source code inside of ASP.NET Core application? We're going to write our first TypeScript class. Then we're going to see how to transpile TypeScript source code and using it from HTML right into the demo now. So in the last part, we created a folder named tutorial. Inside of that, we had a part 1. Now in this part, what I want you to do is to copy the part 1 and then create another folder named part 2. I'm going to copy that and name it part 2. Then we will jump into part 2, and then our name of the application is modern. Then launch Visual Studio Code by typing code dot, which indicates that you're launching code on the current directory. Let me zoom in by pressing Ctrl++. Okay. Now let me close this Explorer by clicking on this. This is a toggle button. Okay then. Now let's see how to how to install TypeScript and why I chose TypeScript. I've chosen TypeScript for a reason because it's a superset of ECMAScript and also it supports types. There are other choices. People could use Babel. Babel is another very popular transpiler, but TypeScript is much better than Babel because Babel doesn't do type checking, whereas TypeScript does type checking. So I would rather go with TypeScript. If you can see, TypeScript is all about types. So type checking during transpile time is very valuable. In order for us to do the type checking, TypeScript needs TypeScript definitions or type definitions for pretty much all the popular JavaScript libraries. We are lucky that there is a site called TSD, which is TypeScript definition. They maintain a lot of those type definitions for the popular JavaScript libraries like jQuery, Moment.js, etc. Luckily, the modern and new JavaScript frameworks like Aurelia, Angular, React, they all ship with D.TS. Okay, then now let's look at the package manager, which is going to be npm. There are other package managers out there like JSPM and Bower. I'm not going to be installing them. I'm not going to be installing or using any of those package managers because npm is more than enough because it has a lot of client-side libraries and server-side libraries hosted in there, and that's more than enough for me. So let's talk about how we're going to install the client tools and libraries. To install TypeScript, you want to type npm install TypeScript at next, which means it's going to get the nightly build, and you want to install it globally. So you'll use the -G switch. Since I've already installed it, I'm not going to do this. And you also want to install another tool called Typings tool. This is replacing the TSD tool, which is used to fetch the D.TS, which is type definitions for popular JavaScript libraries. I've already installed Typings as well, so I'm not going to do that. Then what we want to do is we want to also install these tools locally. So that requires the command npm install with a --save dev. When I hit enter, I might get an error if I don't have npm initialized on my local folder. If I get an error, it's very easy to initialize it because we can just do that by using npm init. Like you can see that it complains about package.json missing, which means that I haven't run the npm init command. So let me initialize my package manager. So I'm going to hit enter for most of them. I'm just going to put the author name as my name and hit enter for other things. And I'm going to say, okay. So now if you do the directory listing, you'll see that it created a package.json. Now let me run the same command again. It's going to install it, and this dash dash save deb means it is a development time dependency and not a runtime dependency. So package.json is going to make an entry into the into its dev dependencies section. We can open the package.json and I can show you where it's going to add that. As you can see, it added the TypeScript as a dev dependency, and we are going to be using 2.0.0 development version of TypeScript, which is the latest and greatest. And then we're also going to do the same thing for typings as well. We'll install the typings tool, and we'll also make it as a dev dependency. And as you can see, as soon as it's done, you can see the Visual Studio Code refresh the package.json, and you'll be seeing an entry for typings as well. Once it's done, what we're going to do next is to check the version of TypeScript and the typings version, which you can always look at the package.json, but you can also ask TypeScript itself. The name of the TypeScript compiler is TSC, and the switch is -v to display the version number. And as you can see, it displays the same version that you see in the package.json. Similarly, you want to type typings-v as well, and that's going to give me the version 1.3.1. Now that we set up the tools, let's see how we are going to organize the project source code. So the first thing we want to do is, if you look at the folder structure, there's a folder named www, which is what the ASP.NET Core Kestrel will use to serve the client-side files. Since we already have that folder, we don't need to create it. Then we need a place to store all of our TypeScript files. As I told earlier, TypeScript is not going to be directly run inside my browser, so I need to transpile that. So what I want to do is, I don't want to pollute the www folder, so I'm going to create another folder named source at the same level as www. So let me call the name of the folder source. And as a convention, I always want to create another folder named app to imply an application underneath that. Now that we created the folder structure, let us create our first TypeScript class. Let me create the first TypeScript class and name it greeter.ts. TS is the extension for TypeScript. Okay, now let's create the class greeter. Then I'm going to create a constructor, and you can use tab out. And if you want to declare a field within a class, you have two choices. You could declare the field explicitly by using the private or public keywords. Private and the name of the property. In my case, I want to call it message : the type. This is one way of declaring. There's another way to declare a property inside the constructor itself. Like, for example, in this case, if you don't want to declare the field and then initialize it later inside the constructor, like this, let's say I'm going to call this also as message string, then usually what you do is use this reference and you assign that to the incoming argument. See, now this is too much of typing and too much of decoration. TypeScript allows you, and it gives you a shortcut where you could just say private here itself. And then you can delete this field. It'll automatically create this field for you. And you no longer need this assignment because that parameter itself is going to create the field and assign it automatically. So let's take advantage of this shortcut. And you can see that green squiggly because that's TS lint running. It says that do not have trailing white space. It's just for, aesthetic sense. I mean, it's not really an error. It's just saying that we have too much white space. And it's always a good idea not to leave too much of white space. So I'm just going to delete the white spaces. Now that we've declared the constructor, I'm going to declare another method called say hello. And I'm going to just use console.log to log the message. I am going to use the ECMAScript 6 or TypeScript string interpolation. Hello. And then you can use a dollar curly brace, the name of the variable to display. In this case, I'm going to display the field this.message. I'm just going to say hello, the name, the value of the property or field from TypeScript. And I'm also going to declare another you know, property accessor syntax using the getter get and then name of the property, and then you have to declare the return value, which is string, and I am just going to say return and the same message that we have printed in the previous method. Cool. Now we've completed the first TypeScript class. Okay, then let's look at the folder structure once again. Source app greeter.ts. Like I said, the browser or HTML cannot directly use the TypeScript file. It needs to be transpiled into an ECMAScript 5 JavaScript file. How do I transpile it? I could use the TSC compiler from command line. I could type TSC and then I could say star.ts or a folder name where the TS files are there. But I'm going to take the approach of creating a TypeScript project. What is a TypeScript project? It's very simple. You go to any folder, you create a file named tsconfig.json, and you put some parameters that will be used by the TypeScript compiler. Then that folder automatically becomes a TypeScript project. Let's do that now. Since we want to be able to we want to be able to compile any TypeScript files in any of the folders, I would always put it at the root. So I'm going to create a file named tsconfig.json. Oops, I typed two N's. I'm going to rename that. Okay, then I will copy and paste the tsconfig.json that I already prepared over here. And then let's do some formatting. Okay, the first option is compiler options, and it has lots of sub properties. Target is ES5, and the module system that I want to use is the common JS module system. You might be familiar with other module systems like AMD, UMD, and you know, ECMAScript 2015 module system, and so on. So let me explain what all these properties are all about, and then we can start compiling or transpiling. Okay, so we talked about target, we talked about module, inline source map. What is a source map? A source map is very useful when you want to debug your TypeScript application from within the browser's developer tools or debugging tools. For example, you have the debugging tools available in Chrome, Firefox, and the Edge browser from Microsoft. All of them support debugging. I mean, like it is commonly called as F12 tools because the F12 is the function key that we use to launch those debugging development tools. And inline sources is related to the inline source. It says emit the source alongside the source map within a single file. So you need these two properties to be set together. And then source root, because what I'm going to do is I'm going to generate the output inside this www root folder, which means that I need to tell where is the source file coming from. That's what the source dir is all about. Source root is all about. And then out dir is where should TypeScript copy the generated JavaScript files. So it's going to be under www/root/app. So how do I run it? Okay, I have to run it from the command line. So there are two choices. I could just type tsc. By default, if you don't pass any parameters, it'll look for the file name tsconfig.json, which is on your left side of the screen, and it'll follow the settings there, and then it'll start generating the JS files. There's another option which is called watch. What it does is it'll keep an eye on all files that ends with .ts extension. Anytime you make some changes and you save, this watcher wakes up and then transpiles them right away. So I'd rather go with the second option. So I'm going to just say tsc-watch. So you can see that the compilation is complete, and you can see that the app greeter.js file appears there because the TypeScript compiler transpiled it. Let's go take a look at it. As you can see, it is a ECMAScript 5 compatible JavaScript function, which is equivalent to the TypeScript version of the source code that we wrote. And as you can see at the bottom, it has an inline source map. It contains the base64 encoded source mapping URL and other artifacts required by the browsers to debug using the developer tools. Okay, then let me close this. And now that we have the file generated, it's very easy for us to call it from an HTML file. Here we go. Let's go to www root and create a file named index.html. HTML. And I've already prepared the index.html file. I'm not going to type it. So I will copy and paste it from my other screen and we'll just format it. Okay. So it has a title that says welcome to ASP.NET Core 1.0. And then I've had a script tag. I'm not going to be showing how to use the module loaders in this part because in the future parts we'll be using TypeScript along with Webpack, and Webpack has something called as TypeScript loaders, which there's one loader called Awesome TypeScript Loader, and I'll use that to transfile. And also Webpack comes with its own module system, so I don't need to go out of the way to declare the modules here and use the module syntax now. So that's why I chose to go the simple script source route in this part. Okay, so we're almost there. Let's close the curly brace and close the tags. Okay, then now you should be able to see everything. Okay, let us go format them. Actually, we should be able to use the tool to format. Um, okay, we need the closing HTML tag. That's all we need. There we go. And I think we should be able to format the code using the view. There is a command palette. You hit F1 to bring the command palette, and then you can say format code, and yep, that did the trick. So let me walk through this simple HTML file. The script source tag includes the generated greeter.js file from the TypeScript file, and then we have a blank div with an ID greeting, and then we use the standard DOM manipulation JavaScript, which gets the document by the element ID greeting, and then we assign the inner HTML to the greeter object that we create with an argument world. So it is going to say, it's going to call the greeter object greeting message property. If you remember that property, if you look at the property, it's going to say hello, and then the value of the parameter that we pass. The value of the parameter in our case is going to be hello, sorry, world. So it's going to display hello world from TypeScript, and it's going to return that through this property greeting message. And that's what we're going to insert into the div with an h1 tag. Okay, now that we've done that, we need to go back to our startup.js. Like I told, everything needs to be configured and used. In our case, what we're going to do is we need to be able to let our ASP.NET Core serve static files. So I'm going to use the method app.use static files. You may not get IntelliSense now because remember I told that you need to add the assembly dependencies into project.json. So app.use static files, and then let's go to the project.json, and we need to include the static files dependencies. Microsoft.aspnetcore.static files is the name of the assembly, and that version number is going to be 1.0.0. Okay, now I think we're all set. Let's go back to the index.html, and I don't think we need to be on any particular file. Let's hit F5 now to launch. Hit F5 again. Okay, I think it is having a problem running the launch configuration. Let's take a look at what's going on. I guess we need to launch it from this launch area for the first time. Then it builds and then it launches it. Okay, why are we getting Hello World from ASP.NET Core 1.0? Remember, this index.html is a static file. So unless we ask for it explicitly, it's going to fall back to the ASP.NET map, ASP.NET MVC map route, and map route is going to look for a controller and a action. Since we didn't provide a controller and an action, it's going to fall back to the home controller and index method, which is returning this string. So how do I force it to return index.html? Let's bring the developer tools, and then hit /index.html. And now you get the message hello world from TypeScript. Remember I told that because we generated the inline source map, we'll be able to put a breakpoint inside the JavaScript and as well as the TypeScript file. So let's go to the TypeScript file. Let's put a breakpoint there. And then let's do an F5 again. And as you can see, we get full debugging support, and also we are able to see that we called the greeter constructor with the message world, and that's what we are returning back into the application. You can also go in index.html and you can put a breakpoint there as well. And once you say resume script execution, it's going to come back and then assign that value into the div. Congratulations, we are now able to set up a TypeScript typings tool, and we're able to invoke TypeScript, and we're able to create a class. We're able to transpile and use the resultant JavaScript from within our index.html. In the future part of the series, I'll continue with how I could set up Webpack and Aurelia, the most popular modern JavaScript framework for building SPA applications. SPA is single page applications. Until we meet in third part of this series, bye bye. Thank you so much for watching this video.